rates of change of the polar function graphs. Okay, so we had these polar functions yesterday, and we will spend some more time looking at those. They were neat, and I want to really deep dive there, but not today. Today we're looking at how they change. It says the distance between f of theta and the origin is increasing. The distance between f of theta and the origin is increasing if r is positive. If r is positive and increasing. So your signs have to match. Either r is positive and increasing, or r is negative and decreasing. Then you can tell the distance between f of theta and the origin is increasing. Okay? If your signs are opposite, r is positive and decreasing, or negative and increasing, then the distance between f of theta and the origin is decreasing. What in the world? Okay, so if the polar function changes from increasing to decreasing or vice versa on the interval, then it has a relative extreme. So we're looking at data points, and we're seeing where's the change. Where is it changing from increasing to decreasing? Look at this table right here. Don't worry anything about the function. Where can you tell that there's a change?
4.
Pi over 2, comma 4. Can you see it? Because from 0 to pi over 2, our data is increasing. And from pi over 2 to pi, it's going 4, 3.520. 0. It's decreasing. So therefore, there is an extreme at pi over 4, 4. Can you tell? Okay. And actually, it would be 4 comma pi over 4. We graph it r theta. R comma theta. Yep. Pi over 2. Just take it all off. Okay, so given r of theta equals 4 sine theta, on theta, or on 0 to pi, use the table and graph to complete the statement. So we've got the table here. We're going to be able to analyze that. We also have a graph here. We're going to complete these statements. It says on the interval from 0 to pi over 2. So that's this first interval. R of theta is positive. R of theta is positive. Well, how do I know that? Because my numbers don't have negatives in front of them. Okay? So it is real common sense here. They're positive. And what are they doing? Positive and increasing. Can you tell that those have the same sign? This is up and up. Positive and increasing. Therefore, the distance between r of theta and the origin is increasing. If they're both behaving the same way, then it's increasing the distance. They could have been negative and decreasing, and it would still be, the distance would be increasing. You understand? Over the interval from pi over 2 to pi, so now we're talking about this interval, r of theta is still positive. Still positive. How do I know? Because my numbers don't got negative signs. So they're positive. But what are they doing? Decreasing. So the distance between r of theta and the origin is decreasing. It's getting closer to the origin. Now let's look at the picture and see if we can make sense of that. Because we can understand that in the table. I'm a table girl. The numbers don't lie to me. I start looking at a picture, and all of a sudden, it's twisty. So let's look at this picture. Where is 0 to pi over 2? On this interval, our numbers are positive, and our numbers are increasing. They're going up. Thus, the function's distance from the origin. Look at the distance. This distance from here to here is increasing. All the way up to 1. Can you tell? On the interval from pi over 2 to pi, so that's from here to here. We're looking at this particular section. They're still positive, but they are decreasing. So they're getting closer to the origin. Yeah? Are we making sense of it based on the picture? Nope. Not Macy. Cameron, you want me to walk through that again? Did you see it? Okay, so let this be 0 and let this be pi over 2. As we travel on this circle. Oh, cancel. Our numbers are positive, so we're going up. And they're increasing. They're getting taller. Right? So the circle is going away from the origin. Increasing distance. As we turn the corner, right? So pi over 2 was the turning point. That's where it changes from increasing to decreasing. Now they're coming back, and the distance between is getting smaller. Okay? At what value on 0 to pi is the polar function furthest from the origin? What's the extreme? At theta equals pi over 2. What distance is it there? 4. Yeah? We can kind of wrap our heads around this? Oh! Okay, so this has r of theta equals 4 cosine of 2 theta. This graphs the flower petals, the rose, that's what it was called. Use the table and the graph to complete the statements. I noticed a couple of things when I was working on these problems earlier. This number 4, that's your amplitude. That is the distance that each tip of the rose petal is away from the x-axis. So if you wanted to make a petal that seemed to be larger, you would increase that number. That number is the distance that the tip of the petal is from the origin. Okay. The B number here, if it's even, tells me how many petals there are. You do B times 2. So this is 2 times 2 gives me 4 petals. 1, 2, 3, 4. Right? If that number is odd, so say it was 3, how many petals would you have? 3. So the number of petals is equal to odd B is 2 times even B. Okay. On the interval from pi over 4 to pi over 2. So we're looking from pi over 4 to pi over 2. R of theta is, let's say, negative and decreasing. So what's happening to the distance it is from the origin? It's increasing. How do I know? Because both signs match. The distance from the origin is increasing. So r of theta on pi over 4 to pi over 2. These numbers are negative, and they're decreasing. They're getting more negative. Because they have the same sign, negative and decreasing, the distance from the origin is actually increasing. On the interval from pi over 2 to 3 pi over 4, so that's right here, what are they? R is still negative, but becoming less negative, so increasing. So the distance between r of theta and the origin is decreasing. Is that making more sense? Did you get them straightened out? Thanks.
Yeah, she just needed help.
Lies. Okay, so on the interval from pi over 4 to 3 pi over 4, what's the furthest distance? So from pi over 4 to 3 pi over 4, what's our furthest distance from the origin? Right here. So only pi over 4 to 3 pi over 4. Negative 4. So furthest distance, distance is absolute value of displacement. So 4. 4 is the greatest distance. Oh. I wondered. I'm like, what did she say? 6? Sometimes I just ignore whenever y'all say weird answers. I'm like, Yeah, 4. 4 is what she said. She said 6, but she meant 4. I'll give you the benefit of the doubt. It happens all the time. Like, all day long, people just say the absolute wrong thing. And I'm like, yeah, you're close. Yeah, 4. The problem is, Jenna, you're smart enough to know I did that to you. That's a problem. I do that to kids all day, every day. Yes, increasing. Just what you said. It happens a lot. Okay, look at example 3. It says, given this function, r of theta equals 4 minus 2 sine theta. Remember that these are not going to graph the flowers. The flowers happen if I just have amplitude and the trig function and a b theta. This would do the bean or the heart or the loop-de-loo on the inside. This is the bean, kidney bean, right? At what point in the interval on 0 to 2 pi is the polar function closest to the origin? When is it closest to the origin? At pi over 2. How can you tell that that's an extreme value? So it goes from decreasing to increasing. That's a turning point. So at pi over 2, that is the point closest to the origin. And then this give a reason for your answer. Theta equals pi over 2 is closest. Thank you. Because r of theta changes from decreasing to increasing. Those turning points indicate extreme values. Understand? At what point on the interval from 0 to 2 pi is the polar function farthest from the origin? 3 comma. And so it's going from increasing back to decreasing. Let's talk about what you know as far as extreme values go. Anytime a function's going from decreasing to increasing, well, that's a minimum, right? And anytime a function's going from increasing back to decreasing, that's a maximum. So it feels like that makes sense. That's why is a polar function furthest from the origin. And doesn't that relate on this picture? At 3 pi over 2, isn't it the furthest away at 6? So theta equals 3 pi over 2. And your reason, give a reason for your answer, would be because r of theta changes from increasing to decreasing. Perfect. Yeah. Are you good? No. There's a whole nother side. Are you looking at the same paper I'm looking at? What do you mean, is that it? We got halfway through it. Okay, going on. Moving on. Average rate of change. Average rate of change. So when you see this particular phrasing, rate of change means slope. So you need, what was that? Rate of change means slope. So you need to already have in your brain y2 minus y1 over x2 minus x1. Now this is like kindergarten baby slope, right? This is what you learned in Algebra 1. As we have moved into big kid land and bigger math, we now call it f of x2 minus f of x1 over x2 minus x1. But what if I'm dealing in this polar world?
R of theta 2 minus R of theta 1 over 2 minus theta 1.
Absolutely. No question mark. This is your average rate of change. Okay, so we're taking what you learned in Algebra 1. How do I find the rate of change of a graph? Y2 minus Y1 over X2 minus Y1. How do I find the average rate of change on any function, not just a line, f of, right? And now we're going into polar land. How do I find the rate of change on a polar function? R of theta 2 minus R of theta 1 over theta 2 minus theta 1. And so you don't even have to really know a whole lot more. We're just able to plug and chug here. So use the polar function R of theta equals 4 minus sine theta. Given an example 3. Find the average rate of change of R with respect to theta on the interval from 0 to pi over 6. It wants you to use the table given on example 3. So we don't have to put this in your calculator right now. In the future, we will. Okay, so right now, we're just looking at our table. We want the average rate of change on the interval from 0 to pi over 6. So we want R of pi over 6 minus R of 0 divided by pi over 6 minus 0. So somebody look back at your table. R of pi over 6 is 3. R of 0 is 4. Divided by pi over 6 minus 0. Y'all following this? 3 minus 4 is negative 1 over pi over 6. We multiply by the reciprocal. So our answer here is going to be negative 6 over pi. That's our average rate of change. Now this rate of change came out negative. What does that tell me is happening to my function? It's decreasing. Is the radius increasing or decreasing? Well, it's decreasing. Because the average rate of change is negative, is less than 0. Doesn't that make sense? It's decreasing because the average rate of change came out to be negative 6 over pi. It's negative. So that tells me that the rate of change of the radius is decreasing. Yeah? Okay, calculator time. We're going to try this, and we're going to try it not taking 79 minutes.
Graphing or what?
No, it says given R of theta equals 3 plus 3 sine theta. So you're going to put that in your calculator. Find the average rate of change of R with respect to theta on the interval from 0.4 to 0.6. It is different. Okay, hey, flower girls, find your calculator. That's y'all. Find your calculator. You're going to need it. We're already on a roll. Here I go.
That's 2.
This is number 2. Find your calculator.
Oh, God.
We're going to put this function, R of theta equals 3 plus 3 sine theta. This one right here. R of theta equals 3 plus 3 sine theta. Okay, so on your calculator, you're going to go to your home screen. And you're going to put add calculator. And you're going to do menu. Do you see where it says graph, entry, edit? Graph, entry, and edit. Nikki, help. Menu. You see where it says graph, entry, edit? On your grapher. Are you ready to graph?
Did you not just say add calculator?
Add graph.
Hold on.
Pause.
Menu.
Graph entry edit. Go down to number 5. Do you see where it says polar? So you're going to pick number 5. Now you should be able to type it in. But when you get to theta, so you got 3 plus 3 sine, open parentheses, right? 3 plus 3 sine, open parentheses. Push your pi button and slide over to theta. It's on the top row because you can't use x here. And then enter.
Looks like a bean.
Is it pretty? Or is it a bean? Okay. So now we've got our function in y equals, right? So now we need to be able to go to the home screen. So push Control Dock. Go to your home screen, Control Dock. And now do a big fraction. Control Divide. Var. R of, and our first number we're going to put in here is 0.6 minus R, so var, of 0.4. So we're doing R of 0.6 minus R of 0.4 divided by 0.6 minus 0.4 because they gave me this interval. Another way they could have given me this information is on the interval from 0.4 to 0.6, and we would see interval notation. Did you get a number? What, pray tell, is your number? 2.63836. 2.63886, so
Take out 2.628.
it's 2.63. What are the units for the rate of change? Well, they said suppose the radii of the graph are measured in centimeters. What's theta measured in? Radians. So these are centimeters per radian. Estimate R of 0.5 using the rate of change found in A. Estimate R of 0.5. Okay? So we're going to estimate R of 0.5. So here's what I did. On mine, I went old point slope form. Y minus Y1 equals M times X minus X1. And I'm trying to find R of 0.5. So I have slope is 2.63.
So you do R 0.5.
I know that I have R of 0.4 here. So R of 0.5 minus R of 0.4 is equal to 2.63 times 0.5 minus 0.4. Are y'all following this? No. This is point slope form. Y2 minus Y1, or Y minus Y1 equals M times X minus X1. And my X values are 0.5 and 0.4. And my Y values are R of 0.5 and R of 0.4. So R of 0.5 is going to equal 2.63 times 0.5 minus 0.4 plus R of 0.4. So on your calculator, you should be able to type this sentence. 2.63 times 0.5 minus 0.4 plus R of 0.4. Anybody get a number? This is estimating R of 0.5. Let's go 3. 3 decimal places. Okay, 4.431. 4.431. We agree? Did you get that? Excellent. So I just rearranged point slope form. Solve for R of 0.5. Okay. Now it says find R of 0.5. So how would you do that? Type on your calculator, R of 0.5.
4.438.
Okay. So R of 0.5 is actually 4.438. Is your estimate close to the value? I would say yeah. They're only 7 thousandths away from one another. So yes. They differ by 7 thousandths.
My mom said this one just sleeps with me better, but it's like rubbing right here. It's like mesh, so.
Any questions here? Hey, that's enough to do the worksheet that goes with 314 and 315.